Alright, welcome back. We're on the home stretch now of Module 2, Georeferencing. I got some water handy in case I have another coughing breakdown. I apologize for that in the last video. I'll try to stay straight this time. What are we going to do? Well, what did we do last time? I talked about common projections. Basically, transverse Mercator projections for things that are oriented north-south, and conic projections, Lambert conformal conic projections for things that are oriented east-west in the conterminous United States. There's one other coordinate system that's used a lot in the United States, and that's called the Public Land Survey System. And this is a map that shows the Public Land Survey System, so it's actually a system, a collection of coordinate systems that describe land parcels throughout most of the United States. And this started right after the Revolutionary War. Thomas Jefferson proposed that it happen. After the war's over, the federal government gets a lot of property from Britain, and they want to use some of that property to give it to the soldiers to reward them for their service. And they also want to sell some of the property so that they can run this new government that they have. So in order to sell things and give them away, they need to define them, because there's places out west, which isn't very far west back then, that nobody's really been. So you need to be able to define them before you can give them away, otherwise you don't know what you're giving away. So Jefferson proposed this public land survey system, and it gets implemented over time in different places at different times, and that's why you see these different colors on the map, because the surveys occurred in different places at different times. So you can see in the Northwest there was a survey of Idaho that looks like it was undertaken in about 1867, Montana 1867. This was an Indian reservation back here, the Wind River Indian Reservation, 1875. And then you go to the west a little bit and you see that Washington and Oregon was done in 1851. And why would that have been done before this? Well, there was more going on out here, and so they needed to survey that country so that people could deal with property transactions and all that. So Washington and Oregon actually got done before Idaho got done. Okay, enough of that history. How does it work? Well, what the Public Land Survey System does is it breaks up the survey into a grid, kind of like a raster model does. And the grid is made up of cells or squares that are 6 miles on a side. Each cell or square is called a township. So each township is 6 miles wide and 6 miles high. And you can see that the townships start at an origin for like a coordinate system. And the east-west axis of the coordinate system is called the baseline. The north-south axis is called the principal meridian. So the origin is the intersection of those 2 points. That's sometimes called the initial point. As you go north from the origin, you increase in townships. So Township 1 north, Township 2 north, Township 3 north. When you go south, you replace the north with the south. Further away gets higher numbers. Similarly, across the meridians, we have what are called ranges. Range 1 east is the first township east of the meridian, 2 east, 3 east, and so on. So here we're looking at one township. It's 6 miles by 6 miles. And they subdivide that township in what are called sections. So a section is 1 mile by 1 mile. And there are 36 sections that fit into a township, and they're numbered in kind of a strange way, and it's a serpentine way. So you start in the upper right-hand corner with section number 1, and then you proceed to the west, 1, 2, 3, 4, 5, 6. You go down to the next row, 7, 8, 9, 10, 11, 12, and you proceed in that serpentine fashion until you get all the way to the bottom, which is section 36. So this is how you're going to designate parts of a township. Okay, so here we have our initial point, the baseline, principal meridian. We can be in Township 2 north, Range 2 east. That would be this township right there. This township would be Township 2 south, Range 2 west. And this is an exploded view of that township. It's got 36 sections in it. This section that's green is section 13 of Township 2 South, Range 2 West of this survey that's associated with this principal meridian and this baseline. So you can go down further than these sections. Remember, sections are a mile by a mile. You can break those sections into what are called quarter sections. So that's a quarter of one section, which would be a half mile on a side. And you can go ahead and break it down even further to quarter sections. So here we have 4 quarter sections in the northeast quarter section in section 13 in Township 2 South, Range 2 West. And you can continue to break each one of these quarter sections into what are called quarter sections. And similar as this breakdown works, you would have a northwest and a northeast and a southeast and a southwest quarter of this section of this township. So that breaks things down so that you can describe property locations based upon where they're located on this grid. This is another graphic that kind of shows you this and how you get down to the smaller areas. When you get to a section is going to be 640 acres total. So each quarter of a section is going to be 160 acres. Each quarter is going to be 40 acres. And a quarter section is going to be 10 acres. So you're easily able to break the grid down into 10-acre pieces of land. And you can imagine if you buy a 10-acre piece of land, you would be able to designate its location. One of the things that makes you realize that you're out in this public land survey system is when you're driving along and all of a sudden, let's say you're driving on the road and all of a sudden the road takes a 90-degree angle to the right, and then you go a little ways here, maybe about 1/8 of a mile, I guess that would be, and you take a hard left and go 90 degrees to the left. And so when you're driving on these perpendicularly oriented roads out in the country, you're generally following section lines. And that actually has an application when you get data that's like an image that has the roads on it. Sometimes you're able to use the location of those roads to decide that that is where you're going to geo-reference your data because you know where that section is on the map. Okay, in Idaho, the initial point where that principal meridian and the baseline meet is south of Boise, south of Kuna actually, down between Kuna and the river. Those of you that have driven down there by the Raptor Refuge have noticed this kind of knob off to the east of the highway with the old beaten up concrete in it, and this is the initial point for Idaho. So that's where everything started. Looks like vandals came out here and wrecked it all, but the initial point is still there. Okay, so that's all the new stuff we're going to cover this week. But what have we covered? Boy, it's been a long week. Talked about ellipsoids, smooth mathematical representation of the planet. Geoids, physics representation of gravity. Coordinate systems, spherical and planar coordinate systems. Map projections, developable surfaces. Distortion. Projection equals distortion. Common projections and map scale, which I don't show here, but scale. And finally, public land survey system. So I covered a lot of stuff this week. It's been a tough week. This is one of the harder weeks in terms of staying involved in things. So if you've made it to this point, congratulations. Next week, I'm going to start talking about data quality and metadata, because when we have these GISs that bring in data, we need to talk about the quality of the data, the standards that the data follow, and how we're going to describe what that data is, because we're going to find out that if you put bad data into the system, it doesn't matter how good the system is, you're going to get bad information out the back end. Okay, as a bonus, if you're still hanging in there and you want to go see something that's a little bit funny, there's a YouTube clip out there, and this is a clip of an old television show called The West Wing, and it's associated with map projections of all things. So I thank you for viewing and enjoy watching that clip, and come back next week for week 3.